This module covers terrain analysis, and the learning outcomes of this module are terrain analysis and terrain variable understanding, calculation of slope and aspect from DEM, and delineation of watershed and stream network from DEM, and delineation of viewshed from DEM. So first of all, what is terrain analysis? It's the analysis of a stretch of land and the interpretation of its physical features. So it primarily involves the elevation information and related quantities. Some of the things of interest could be which way the water will flow, um, or how much water will be contributed, or how much area will contribute water to a given point, or visibility in a mountainous region, which area is visible from a given point. All of these are related to terrain analysis. And in GIS, there are three data sets that you will often come across for terrain analysis. These are digital terrain model, or DTM, digital elevation model, or DEM, and digital surface model, or DSM. And following slides describe all of these individually. A digital terrain model, or DTM, is a vector data set. It's composed of regularly spaced points or natural features such as ridges and break lines. Often you will see that a DEM is a base image, and some form of DTM is drawn on top of it. So in this image, the DEM is the raster data set, and DTM is the contours on top of it. Here is another where we have the DEM as a 3D visualization with contours mapped on top. So contours are the DTM part, or digital terrain model. One thing that you need to be careful about, that DTM does not include the objects on the surface. It's the bare earth terrain model. So if you have buildings and vegetation, you do not include those in the DTM and also DEM. It just provides the information about the bare ground, bare earth, or the ground surface without objects on top of it. The digital elevation model is the same information as DTM, but in a raster format. It's still a bare earth raster data set. So it's X, Y, and Z provides the elevation information, but it's in the form of a raster image. Again, it does not include any non-ground points such as roads, bridges, power lines, buildings. The last one is the digital surface model. Now, this is the model in which natural and built features are included. So if in this image you can see that on top of the elevation, all the objects are placed as well. So this is a digital surface model. When we use LiDAR data, which we have talked about in remote sensing, the LiDAR point cloud includes both the surface, ground, and non-ground features, which are vegetation and buildings. So when we remove these non-ground features and only display the ground features, that would be digital terrain model. But when we include these surface features, then it will become a digital surface model. So in surface model, we actually have all the surface features included. Some of the variables that you will come across in digital terrain analysis or terrain analysis are the height, which is the elevation. That's kind of the starting point of everything. So once we have the elevation, we can do all sorts of things with it. So the first one are slope and aspect. Slope is the rise over run, and aspect is the direction of the steepest slope. Then we have the upslope area, flow length, and upslope length. And these are of interest in the watershed analysis, typically what area contributes to a given point if it was raining. Then we have the profile curvature, plane curvature, and these are also variables that are of interest in flow, water flow, and water flow convergence. And lastly, we have the visibility, which is a variable of interest in if a site is being obstructed by another structure, for example, a building being obstructed by another building. All of these analyses and all of these variables can be calculated from height, the digital elevation model or digital terrain model.